Hi everybody, welcome back to Dave's Math Channel. I'm your host David Tare, and this is my continuing feature on the Math Lovers book. Today this is my last video on my sub-series on cardinal numbers, with section 5.6 of chapter 5, which is on set theory. And this is going to be my last video on set theory. Tomorrow I'll start new chapter 6, which is on group theory. And group theory is a very important area of math, and it's fun too. So I think it'll probably be more fun than set theory. A little more difficult, but a lot more important and a lot more fun, I'd say. But anyway, I'm going to wrap up my discussion of set theory with a discussion of the generalized continuum hypothesis. As the name suggests, this is a generalization of the continuum hypothesis, which I went over a couple lessons ago. So anyway, let's begin. And this is going to be a pretty short lesson. I only have one slide where I say what the generalized continuum hypothesis says. And like the continuum hypothesis, it turns out that this is something you have to add as assumption. Either it or its negation as assumption, another postulate of set theory. But what the generalized continuum hypothesis says, remember the continuum hypothesis said that there's no infinite cardinal number between aleph null, the smallest infinite cardinal number, which is the cardinal number of the natural numbers, and the cardinal number of the real numbers, which we call C. And another way to say that is that aleph 1 is equal to C, but you can be a little fancier about this. I introduced this bet notation yesterday, I think. So we can also define these infinite cardinal numbers, bet null, bet 1, bet 2, and so on. And the way we do that is we just say that bet alpha plus 1 is 2 to the bet aleph, where aleph is an arbitrary, what's called an ordinal number. I didn't talk about ordinal numbers. This is something else. But formally that's what it says. I mean, you can think of aleph as an integer if you like, a positive integer. Turns out aleph can also be infinite. But just for simplicity, let's assume alpha is an integer. So this would say, for instance, that bet 1 is 2 to the bet naught. In other words, it's the cardinality of the power set of a set of cardinality bet naught, like the natural numbers. And similarly, bet 2 would be the cardinal number of the power set of all real numbers, which is a little hard to imagine. But you can keep going like this. You can keep taking power sets ad infinitum, and each time you do that, you get another bet number. So if you took, for instance, n power sets of the natural numbers, you would get bet n. Or I guess you could take alpha, because you could do this more than a finite number of times if you like. But what the generalized continuum hypothesis says is that there's no cardinal numbers between bet alpha and bet alpha plus 1. And another way to say that is aleph alpha equals bet alpha for every alpha. So you might as well go back to the aleph notation. The bet notation's kind of ambiguous if you assume the generalized continuum hypothesis. And I don't know what the status is. I think I already mentioned in my previous video or a couple videos ago that it's impossible to either prove or disprove the continuum hypothesis, which means that there's versions of set theory in which it's true, and there's other versions in which it's false, which is a little bit of a weird situation. But it's kind of like with Euclidean and non-Euclidean geometry, as I mentioned. So you can have some versions of set theory in which aleph 1 is equal to bet 1 or C, but you could have other versions in which bet 1 is equal to aleph 9 or aleph 15 or maybe aleph omega, where omega is the smallest ordinal number. I'm not going to go into that. But and it might be similar for the generalized continuum hypothesis. I'm not sure about this, but my understanding is that maybe you can make the same kind of assumptions for every gap between bet numbers. For instance, we could assume that bet 45, maybe there's 20 infinite cardinal numbers between bet 45 and bet 46. So I guess my understanding is bet 46 could be alpha 349 and bet 46 could be alpha 369, something like that. I don't know how this works, but it's kind of a weird situation. And I'm not an expert on set theory. I've said everything I know about the generalized continuum hypothesis. So that concludes my discussion on set theory. Like I said, I'll start with group theory tomorrow, which I think will be a lot of fun. Anyway, thank you for watching. Long live math, and I'll see you guys next time. Bye.